All right, so I'm going to help you guys get started on the building atoms activity today. So you should have in your notebooks, turn to that activity section and write behind the lab that we just did last class. We're going to do this activity. So on your blue sheets, you've got the backside that says building atoms activity that looks just like this on the screen. And the first one says draw each of the atoms on your paper and label the electrons, the nucleus, the neutrons, and the protons in the pictures. So we're going to do beryllium together. I'm going to do beryllium on the screen here. And then you guys will have some time to do fluorine and carbon on your own. All right. So let's take a look. Go ahead and draw it on your papers. So I've given you a couple of hints down here, around the surrounding pictures. Because it's kind of hard to tell, in the center, in the nucleus, we have 5 black circles and 4 white circles in the nucleus. Okay. And then on the outside of the nucleus, in those rings, we have 4 as well. 2 in the first ring and then 2 in the second ring. So what we need to do after you've drawn it, you need to label the electrons, the nucleus, the neutrons, and the protons. All right. So let's start with the electrons. Remember from our notes and remember from our gizmo activity that electrons are outside of the nucleus. So these guys here that are outside of the nucleus in the rings are what we call electrons. So I'll just kind of put E with a little negative. That's our symbol for electrons. So those guys are the electrons. Remember, our nucleus is always the thing in the middle. So that thing in the middle is our nucleus. So go ahead and circle it and label it the nucleus. Now inside the nucleus, we have neutrons and we have protons. So we have to figure out whether the black ones are the neutrons or the protons, and the white ones are going to be the other one. So let's take a look actually at, let's determine the number of protons first. So if you remember from the gizmo, the number of protons has to equal the number of electrons if an atom is not ionized. So if an atom is neutral, the number of protons and electrons have to be equal. So if we count up how many electrons we have 4 electrons, right? So that means in our nucleus, we need to have 4 protons. So the only one that matches up is our 4 white ones. So you can say, the white ones, or draw a picture of, or not a picture, but an arrow from the white ones, okay, and call those protons. So if the white ones are the protons, that means the other ones, the 5 black ones, are the neutrons. So the black ones here are what we call neutrons. So they're the other thing in the nucleus that has a neutral charge. So they're not affecting the charge in any way. Okay. So what you'll do is you'll go ahead and draw the fluorine atom as well as the carbon atom, and then just label, just like we did with the other one, each of those parts of the atom. Okay. After you do that, you've got questions 2, 3, and 4 to answer in your notebook as well. We kind of gave some of those clues away as we were talking about the structure of the atom. So answer those questions, and then you should have gotten or will be given a little white sheet with the data table, okay, on it. So please do not copy this data table in your notebook, because you're going to get a white piece of paper that you can write right on, and you've got tape at your desks to put it right in your notebook and start filling it in. All right, so for this part, you're definitely going to need a periodic table. So hopefully you've got one of those as well. What I'm going to do is I'm going to go through a couple of these together, and then the rest of the class period is for you guys to finish up this activity from top to bottom. The part 1 questions 1 through 4, and then part 2 with the table and the questions as well underneath. So let's take a look. We're going to do the first one on the table here, our element beryllium. So if you take a look at beryllium on the periodic table, he's near the top left, and you're going to see the chemical symbol. The symbol is the 1 or 2 letter symbol there. So for beryllium, it's B, capital B, little e. So beryllium is Be. Now the number just above the symbol is what we call the atomic number. And so for beryllium, it's 4. That atomic number is equal to the number of protons in an atom of beryllium. So there's the atomic number is 4. That means there's 4 protons. And remember from our gizmo that the number of protons must equal the number of electrons in a neutral beryllium atom. And we're assuming that all of these are neutral. So that means there's 4 electrons in beryllium as well. So hopefully that makes sense. Again, we're getting all this information from our periodic table for beryllium. Now, in this particular isotope of beryllium that has 5 neutrons, what we need to fill in next is the mass number. And the mass number always is a whole number. Okay? Because remember, the mass is the protons plus the neutrons. So what we're going to do is we're going to take the number of protons and we're going to add the number of neutrons, and that's going to be our mass number. So 4 plus 5 is 9. So in this isotope of beryllium, the mass is 9. So we'd call it beryllium 9. Okay. Now, the last column is for the average atomic weight. And if you remember, we talked about this last time. The average atomic weight you find on the periodic table, and it's the average, hence the word average there. It's the average of all the isotopes for beryllium. Okay, so that's why on your periodic table, it is a decimal number. Okay, on the periodic table. So take a look at beryllium, and you're going to see underneath its chemical symbol, you're going to see the average atomic weight, and for him, it's 9.01. So the average atomic weight is always a decimal number, because remember, again, it's the average mass of all the different isotopes for beryllium. All right, so that's how we're going to fill this out. You're just going to look at the periodic table with the same information, looking at the symbols and the numbers, and you're going to get each information like that. So we're going to do one more. We're going to skip fluorine, and we're actually going to go down to the third one, because this one, the element name is missing. So you might be thinking, how are we going to figure that out? Well, let's take a look at what we are given. So we are given the number of electrons is 6. Remember, in a neutral atom, the number of electrons has to equal what? Number of protons. So if we have 6 electrons, that means we have 6 protons. If we have 6 protons, that is equal to the atomic number. And if we know the atomic number on the periodic table, we can look up the symbol. So look for number 6 on the periodic table. And you're going to see that the symbol is C, and that stands for carbon. So the element name here is carbon, chemical letter C, with 6 protons and 6 electrons. All right, now some of them are going to be, you're going to have to figure out the number of neutrons. And if you remember, we talked about it in the gizmo, and I believe your notes also talked about it. Remember, the mass always comes from the nucleus. So the protons and the neutrons in the nucleus are giving the mass. So to get the number of neutrons, you're going to take the mass number and you're going to subtract the number of protons. So 12 minus 6 is 6 left over. So in this isotope of carbon-12, it has 6 protons and 6 neutrons, because 6 plus 6 is 12. Right? So remember, that's how we get the mass number, protons plus neutrons. So if you're given the mass number and you know the number of protons, you just subtract those two numbers to get the number of neutrons. Very simple little algebra. All right, and then last but not least, the average atomic weight for carbon Take a look underneath the C on carbon and you'll see that it's 12.01. Again, if we added up all of the atoms in each isotopes of carbon, the average weight for all of the atoms of carbon would be 12.01. Okay. All right, so now you guys are going to go back and finish part one, the drawings and the questions there, and then you guys can use the periodic table to finish up this chart as well as the questions underneath. If you don't finish in class, you'll see that it's the first thing for homework. If you do finish and you finish early, go grab a Chromebook and get your notes out of the way. So you guys are going to do electron organization notes. This is different than periodic table organization notes. All right, so both have organization, but this time it's electron organization. So you guys can get a head start on that homework. And then I will see you next class on Friday.